This indoor unit circuit board of the mini-split air conditioner is not working at all. As soon as I supply electricity to it, I turn the power on. You can see here that the circuit board is not turning on at all, and its display is completely non-functional. If we check the main power supply, we first set the multimeter to AC voltages. This is its main common terminal, where the line wire is installed. I will check it. I will place the red probe of the multimeter on the relay, and the second probe on the neutral terminal of this circuit board. After placing it on the neutral terminal, you can see that 225 AC volts are coming through. If I now check the fuse, the voltage won't pass further if the fuse is burnt out. I have placed the red probe here, and I have attached the other black probe again to the neutral. 226 volts are passing through this fuse. This means that the electricity is flowing further towards the SMPS. Now, let's take a look at the SMPS, where the bridge rectifier is installed. I will check the bridge rectifier. I'll place the multimeter probes on the points of the bridge rectifier, one probe here and the other there, to see if the electricity is reaching the bridge rectifier. The electricity is reaching the bridge rectifier, and we are getting 226 AC volts. I will switch the multimeter DC voltages. Here we are getting 316 DC volts, which means the SMPS is properly getting 313 DC volts. Now there could be an issue with the switching IC, so I will check the switching IC. Next in the SMPS, the switching IC that is installed here. Its number is TNY276GN. It's an SMD switching IC. Now I will check whether voltages are reaching it or not. To do this, I will need to check the positive voltages on the capacitor. I'm placing one probe of the multimeter on one pin of the capacitor. I have attached it, and the ground is on the source pin of the switching IC. We are getting 314 volts, meaning the switching IC should be working. However, if it's not functioning, there could still be an issue causing the problem. Through my experience, I've discovered something else. The reason I'm showing this to you is that sometimes the problem lies with the main electrical sources. But in this case, there is no issue with that. Instead, the problem is with the display. Now, how do I know this? Let me explain. Sometimes, when I can't figure out the fault, I perform an experiment by disconnecting all the components. What I did is, I have disconnected the main electric source from the terminal where the relay is installed. If you look at the relay, it's visibly damaged. The customer had previously complained that the unit would shut down completely. After that, the display stopped working entirely. In such a situation, there could be two causes. Either this point isn't allowing electricity to pass, or the fault has affected another component as well. To troubleshoot the issue, I will disconnect all the sensors, motor, and the display. I will separate everything to see if isolating them would help identify the problem. I have gradually disconnected all the components attached to the circuit board. Only the display remains, and I'm unsure whether it's working or not. So I will disconnect the display by removing its connector. After disconnecting the display, I will power the unit back on. I am reconnecting the relay wire that I had recently disconnected. Now I will power on the circuit. As soon as I turned the power on, the PCB made a sound, indicating switching activity, and the relay whose terminal was burned has also been activated. The situation I observed is that after removing the display, the circuit turned on. This suggests that the fault could be in the display. When I disconnected the motor earlier, the PCB didn't function correctly. Even after removing the sensors, the PCB didn't work. However, after disconnecting the display, the PCB started switching, which indicates that the issue might lie within the display. Next, I'll open the display and examine it to see if there's a fault inside. When I opened the display, I observed that the system consisted of several components. There is a microcontroller installed, and there is also a shift register. The number of the microcontroller is SH97F1612A, and the 8-bit parallel out serial shift register has the model number 74HC164. If the microcontroller is short-circuited, this could potentially be the cause of the problem. Additionally, if there is any other short circuit in the system, it could also result in the issue. The main circuit board microcontroller and the display's microcontroller communicate with each other through serial communication. They exchange information and control the display's power, turning it on and off. The shift register, on the other hand, is responsible for controlling the LEDs by turning them on and off. If most of my viewers know this already, you are currently troubleshooting a display that utilizes 4 wires for serial communication between 2 microcontrollers, which reduces the wiring complexity. They probably know that typically a lot of wires are involved in a display. However, in this display, only 4 wires have been used, through which the system is being controlled. These 4 wires, soldered in the PCB, are connected to some resistors, a capacitor, and another large capacitor. Let's check these components to see if any of them are causing the problem. It could still have an issue with them. I hope the microcontroller isn't shorted, because if the microcontroller is damaged, this display won't be repairable. Let's check these 3 resistors. First of all, let's check this resistor. Its value is 10 kilo ohms. The next resistor is 100 ohms, and the value is okay. The third resistor is also 100 ohms. Now I will check this capacitor, and in continuity mode through the multimeter. I have attached the probes and it's showing beep. This capacitor was supposed to block DC voltages, but it isn't doing so. This means the capacitor is short-circuited. The one next to it is also a DC capacitor, and a DC capacitor is supposed to block DC voltage. If it doesn't block it, then in such a situation, the capacitor is considered short-circuited. Let's remove this capacitor from here. It's been taken out now. We'll wait for a while for the circuit to cool down. For now, I've placed this capacitor in a safe spot so that I can confirm by checking the circuit. I will put the multimeter on continuity mode. Now I will place the probes on the soldering pads of this capacitor. It is still showing a short circuit. There is another capacitor connected next to it, so I'll remove that one from the circuit as well. I'll heat it up using the soldering iron and remove it from the circuit. This capacitor is labeled E8 on the circuit. Let me take it out. After removing the capacitor, I'll check the circuit again in continuity mode. It's still showing a short. This means the microcontroller is getting a direct connection through this capacitor and going upwards into the microcontroller itself. The voltages are reaching the microcontroller here. When the MCU is shorted, this issue will continue to be caused. Now I will place the probes on the soldering pads of this capacitor. It is showing no short circuit. There is another capacitor connected next to it. This one is shorted. This microcontroller is shorted, and that's why we will remove it from the circuit. Without removing it, we wouldn't be able to identify where the problem is. So, I'm heating it up now. None of the pins seem to be shorted together. Now, I will check the same points where I began the startup process. The short circuit in this part of the circuit has been fixed, which means the microcontroller on this circuit board is indeed shorted. This is the main cause of all the problems. When a microcontroller gets shorted, it's already programmed, and reprogramming it can be quite a challenge. That's why this display can't be fixed. I'll need to purchase a new display so that this circuit board can function properly. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.